Yes, good morning, everyone. So in the last class, we were discussing about ACL, access control list, right? So why do we use this ACL? To control or permit or deny the traffic, right? To permit or deny the traffic. Now, in this, we have two types of ACL, like we have one is standard and one we have is a extended ACL, right? Now, in the standard also, it has been further divided into number, named. Same, this one has been divided into number and named. So yesterday we discussed that, okay, what happens with the number and name, that in the number, whenever you have given any rule, that rule cannot be edited. Means if you want to delete any specific rules, then what will happen? All the rules will be deleted. But in the case of named ACL, we can delete the specific rules also. And we can even add certain rules on a specific rule number. That is also possible in the case of named ACL, right? Then we discuss about the standard ACL. So here what happened, that whenever you have to create any policies or rules, so here just we will specify only one criteria, that is called as a source IP address. That's all. Correct? No? We don't specify any destination or like port numbers or the protocol numbers. And in the case of the standard ACL, we have seen that here what happens, that all the services are blocked irrespective of the different protocols or different, we can say, services. All the services are blocked here, right? But in the case of extended, it is not there. In this, we will be filtering the traffic, or we will be creating the rules based on certain mode criteria, that is source IP, then destination IP, port number, and even we will assign the protocol. Apart from that, what will happen? It will give you control access. How? We can here, we can like selected services will be blocked. Not all the services will be blocked. Rest all other features are same only. Means here also you have to implement either on the inbound interface or outbound interface. Once the rules we have created, then we will implement. And same in this also the same rule. When you are using extended, and in the extended, if you are using number ACL, then again same. It means if you have created any rules, that specific rules cannot be deleted. Otherwise, what will happen? All the rules will be deleted, right? Same as if you will be using named, then specific rules or specific changes we can do here, right? So when we used to give the command for the means standard, so command was access list. Then we used to write here ACL number, then deny and host. And then we used to write the source IP address. So this is regarding what? This is the regarding the number standard. But when will you write this one in a like using this one extended number? Let's say we are using a number, and in that we are using what? Extended. So you will write first access list, same thing. After that, ACL number, then deny. Then you will write protocol, what you have to deny, protocol. Then you will write host, from where you have to deny. Then you will write source IP and then destination IP. And at last, port number, right? Then permit statement. And at last, we will write the implementation on the interface number. Correct, no? So we'll discuss this using topologies. Let's take a router. And then one switch. And PCs will take, let's say 1, 2, and 3 PCs. 1, 2, and 3 PC. And this side will take one PC and one server. Okay. So let's take one more switch then. Oh, sorry. We have to connect like this, no? From the switch to the server. Yes. Now, the IP we will configure here on this interface is 192.168.1.70/26. Okay. 1.70/26, correct? No? Then what is the IP here? 192.168.1.71/26. Tell me the network address. 192.168.1.72/26. Tell me fast network address for this IP. 192.168.1.73. I am asking you, tell me the network address. 192, then 168, then 1 dot. Tell me fast. Yes, online guys, tell me the network address for this configured IP. Dot 64 or dot 0? How many of you says? See, this is what /26. It means 2 extra. That is going to be 192. 256 minus 192. What is this? 64, right? So when you will start, so 192, 168.1.0, 192, 168.1.63, 192.168.1.64, and 192, 168.1.127. So we know that this 70, 71, 72, and 73 will come somewhere in between 64 and 127. This is my network address for this configured IP. 1.64. Okay. How it is coming, I'm not going to explain you. Already we have discussed several times. So the network address is going to be 192.168.1.64. This side will take one IP. Let's take as 10.1.1.1/24. This one will be 10.1.1.2/24. And this one is going to be 10.1.1.3/24. Now come to this router. Enable config is pasty. See, any host name you can give, right? So, but I am giving it ACL router. Then interface G0/0 IP address is going to be 192.168.1.70, right? 255.255.255.192. Give no shut and give exit. Then interface G0/1. IP address is 10.1.1.1.255.255.255.0 and give no shut and give exit. Configure the IP. Now come to this PC. Desktop IP configuration. What is the IP? 192.168.1.71. 192. And what is the default gateway? 192.168.1.70, no? 1.70. Then come to second PC, desktop IP configuration, 192.168.1.72. 192.168.1.70. Desktop IP configuration, 192.168.1.73. Then this is going to be 192 and default gateway 192.168.1.70. First come to this PC, 10.1.1.2, 255.255.0, and this is going to be 10.1.1.1. Desktop IP configurations, 10.1.1.3 and 255.255.0, and default gateway 10.1.1.1. Done. Now, after this, you try to ping to 10.1.1.1. Pinging, then ping to 1.2, pinging, ping to 1.3, pinging. Yes. Now, how will you verify other services? Like, let's say we're going to verify HTTP. So for that, come to web browser. Give here HTTP, then colon, double slash, then IP address. Let's say 10.1.1.3, the IP of the server. Okay, so it is coming. So if it is like it is written here Cisco packet address, it means we are able to reach a website according to the Cisco packet address. Okay. If it will be not reachable, what it will show you? Request timeout. Even if you try to reach using HTTPS colon, then 10.1.1.3. Right? It means it is reachable. So now we'll create a rule using what? Extended number. Extended number ratio. Rule number 1. Deny ping from 192.168.1.71 to 10.1.1.2. This is the rule number first. Rule number second, deny HTTP same from 192.168.1.71 to 10.1.1.3. Then rule number 3, deny HTTPS from where? 192.168.1.72 till where? 10.1.1.3. This is the 3 rules that we have to create. Okay. Correct. Now come to this router. According to the first rule, I have to deny what? Ping. So give here access list. Then if you will give a question mark, it will show you that if you are using here extended, then you have to use this number. So what is that number? We will be using here 100. Access list and number we have given 100. Then what we have tried here? Deny. So write here deny. Then again give a question mark. It will tell you to write what? Protocol. So this ping is not a protocol. This ping is a utility. So it is coming under what? ICMP. So we have to write here what? ICM. After that, what we will write? Source IP address. So again, you will write the source IP, then you have to write what? Wildcard mask. So better to go with what? Host. So we'll write here what? Host. Then again, give you a question mark. It says you have to write what? Source address. 192.168.1.71. Then what? Destination address. 10.1.1.2. Then at last you write echo. Not required. Hmm? It uses ICMP only, no? Why it uses means? I'm not getting you.
Why we are using ICM?
Because it is telling you to write protocol. Ping is not a protocol, right? It is a service. It is a utility that uses ICMP protocol. That's why. Okay. Then again, access list 100. This time deny what? HTTP. So HTTP is a protocol. It uses what? TCP or UDP? TCP. Then host 192.168.1.70 till which host? 10.1.1.3. And how we will identify that this is going to be my HTTP only? Equal to 80. The port number that we have to write. Correct, no? Port number of HTTP is what? 80 only. Again, you have to create one more access list 100. Deny what? HTTPS. So HTTPS is what? TCP or UDP? Same TCP. Then which host? 192.168.72 till 10.1.1.3. Now tell me the port number of HTTPS. 443. Done. All these three rules we have created here. Next, we have to give command for permit any. Access list 100. Permit. What it says, what we have to permit? IP. Any IP. If you will give access list 100 permit IP any, what it is telling you? Incomplete command. Why? Because you have given for only source any. This any represent what? Source address. It means I have to give it here for what? Destination also. So we have to give here two times any and any. Then now we'll have to implement it. Interface, let's say we are implementing what? 0/0 inbound interface. Interface G0/0 IP access group 100, then in. Okay. Like for this command, we have not given echo. That's why it is also showing you, but we have to write it from here. So all these commands are visible, correct? Now, according to this, if you try to ping, what it says, destination host unreachable. Why? Because we have denied ping from 172, from 71 to 10.1.1.2, right? Now, if I am trying to ping to 10.1.1.3, it is pinging, correct? Next, we have denied what? HTTP, no? From where? From the same PC. So try to access using HTTP. Request time. Why? Because we have denied it. Even if you try using HTTPS, then what will happen? It is able to reach. Why? Because we have denied HTTP, not the HTTPS, because that's why it is allowed. Right? No? Same as you can try it from where? PC2. So come to PC2, web browser, ten dot 10.1.3. Request timeout because we have denied it. Now, if you try to reach using HTTP, then it is able to reach. Understood this? So whatever the rules that we have given here, all the rules are applicable here. And when you will check, these are the rules that we have created here. Now, as you know that what we are using now, extended number ACL. It means if we are trying to remove any single rule, then what will happen? So let's check that. Come to config space T. Try to remove any single rule. Give no. Done. Now check show IP access list. Okay, do show. Do show IP access list. Done. No rules are present. It means all the rules has been deleted. So write down the commands now. Extended number ACL. Access list. Then ACL number. Deny. Protocol. Host. Source IP address. Then host. Destination IP. And at last, equal to port number. One example I will write here. Example. Access list 100. Deny TCP host 192.168.1.70. Then host 10.1.1.3 and equal to 80. Okay. For ping, you will write access list 100. Deny ICMP host 192.168.1.70. Then again one host 10.1.1.2 and this time equal. Then access list ACL number permit IP any and any. Then interface number IP access group, then ACL number, in or out. So what is the benefit of this? Using extended ACL, selected services can be blocked. Rules will be based on source IP, then destination IP, protocol, and port number. Hmm. Source and destination. See, here we have given a source and destination. Here also any and any, two times. No? So from any to any.
In previous standard, we have given the any in the middle. After that, we have given denied.
No, no.
No,
First,
last class
Mhm.
for standard one, we had given denied first. After that, we have given permitted.
Right.
Then it takes the order permitted.
Same here also.
Same.
Same. That's why here it is important to add with the rule number. Even if you will add one more rule, though you have added for deny statement, but if permit is coming first, so it will be permitted. Same sequence. That's why you will find here that we had a sequence number for all the rules. Correct, no? So as the rules has been deleted here, so now we will create same rule, but this time not using the standard, but sorry, this time using extended name. So come to this router, IP access list, or we can do one more thing. Let me configure telnet also, so that we can deny telnet as well. So for that, how will you create the telnet? What is the command to configure telnet? Line VTY, line VTY 02, 1 or 2, then password, admin 123. We are giving this, why we are giving this password? For login purpose. Then give exit. Give here one enable password, ABC123, and transport. For that, you have to give again line BT5 0 to 1 and transport input telnet. If I want it, only telnet should be done, not SSH. Done. Now, okay. So we will add one more rule that I want to deny what? Telnet. From where? Let's say deny telnet from 192.168.1.73 last PC until what? Let's say 10.1.1.1. Okay. So as of now, if you will try to access this device, come to this one, command prompt, telnet 10.1.1.1. It's there. Now give admin 123 and enable, then ABC 123. It means here we are able to access. Now, according to the rules, what will happen? It will not be able to access that. So first come to this router, IP access list, give a question mark. What it says, we have to write here what? Extended. So write extended. Then again, it will ask you to write one name. See, it is telling you a word that can be any name. Tell me a name. IP access list. Let's say block, anything. Then deny. After deny, what we have to write? Protocol. No? If you give a question mark, it will ask you to give a what? Protocol. For the first, what is the protocol? ICMP. Then host, from where we have to deny 192.168.1.71. Then till what is the host? Destination 10.1.1.2. Echo and last we have to write. Okay. Then again, deny HTTP, sorry, TCP, no, TCP host 192.168.1.71 till which host 10.1.1.3 and equal to 80. Then again deny TCP from which host 192.168.1.72 till which host 10.1.1.3 and this time equal to 443. Now tell me for this telnet again. Deny TCP from which host 192.168.1.73 till which host 10.1.1.1 and what is that equal to 23 because it is telnet. Now we have given all the deny statement. Now we have to give it here what? Permit. Permit. What it says, we have to write a what? IP. Then any. Again, it is telling you incomplete command. So one more time. Permit IP, any and any. Then give exit and interface G0/0 IP access group. Then word that we have given here block and it is going to be in. Give exit. Then now again give exit and verify. So IP access list. And this is the all rules that we have given here. Right? Verify. Let me verify the last one only first. So as of now, it is able to reach. Telnet 10.1.1.1. Then request timeout, not able to reach because it is telling you remote host not responding. Same as other, you can try same thing, this one ping. So command prompt ping to 10.1.1.2. Again, same it is showing you this is host unreachable. Clear, no? But according to the extended name, it means here we can delete any specific rules. So come to config space T and try to delete any specific rule. Let's say we want to delete this one only. What we will give just in front of this, give no. Okay. First you have to give your IP access list, then extended, then block. Then you have to give all these things. Now you give no. Again, now give exit. Verify to show IP access list. So IP access list present. All the other rules is present. That specific rule has been deleted. Correct? No? Now, if I want to delete all the rules, then what I will give? No IP access list extended and block. That's all. Given. Now you verify. Show IP access list. What happened? All the commands has been removed. Now, if I want to add certain rules on a specific rule number, how will I add? Just you will write what? IP access list extended. Let's say block. Here I have given 15. Deny. What you have to deny? TCP. Host 192.168.1.71 till which host? 10.1.1.3 and equal to 80. Give exit, give exit, and show IP access list. And see here, the rules has been created on the rule number 15 only. Because we have specified here that this rule I want on the 15 rule, right? Same as you can insert multiple rules between them also, like adding this particular rule. Got it? So write the commands now. Extended, named ACL. So access list, no. IP access list, extended. Then you have to give a name here. Deny, protocol, then host, source IP, in host, destination IP, and equal to, and port number. Then for permit statement, permit, IP, any and any, interface, interface name and number, then IP, access group, and name that we have given there, and in or out. If you want to write example, IP, access list, extended, let's say I'm given block, deny, TCP, host 192.168.1.70, then host 10.1.1.3 and equal to 80. Understood this? Clear? You know how to add specific rules. Just in the front of this, you will add the rule number. That's all. Correct? So this be complete extended ACL and ACL. Any questions? Now we'll start with the network address translation. See, as you know, that to reach the internet, this private IP address is not sufficient. What we always require, public IP address we require to reach the internet. So that's why we need here NAT. What is NAT? Network address translation. It is used to map the private IP address. It is used to map the private IP address with public IP address to reach the internet. Okay. Or we can say it is used to translate the public IP, private IP into the public IP to reach the internet. Because in the IP version 4, we have two categories of the IPs. One is public and one is private. Now you know what are the ranges of the private IP and what are the ranges of the public IP. Already we have discussed when we were starting discussing about the IPv4. Correct? Now there are different methods for doing this NAT. The first method here is static NAT. Static NAT is called as a one-to-one mapping. In a very simple term, this means one-to-one mapping means what? Here, single private IP will be mapped with single public IP to reach the internet. One-to-one mapping. Now, see, for example, let's say we have taken one scenario where we have a router, then we have a one switch, and then we have multiple end devices. Right? Then this side we have taken one server. We'll take one more router. Now it has been connected like this. Okay. This is going to be my router 1. This is router 2. And this is a switch. This is PC1. PC2. And PC3. and this is what? Server. Now on this particular interface, we have IP 192.168.1.10. Here we have 1.1. This is 1.2, and this is 1.3. Okay. Now here we have one public IP. Okay. 100.1.1.1/29. Okay. So, and I need this side also. Let's consider this side we will be 100.1.1.2/29. Correct, no? And this side we have one more private IP that is going to be, let's say, 192 or 10.1.1.1. And this is a server where I have IP 10.1.1.2. Correct? Fine. Now, if you have to communicate, like this PC1 has to reach this server. So this server is located in the on the internet. Okay. Now to access this server, what this PC1 want? Public IP. So here, if you will see here, we have one private IP and one public IP. If this particular server has to reach, like if this PC has to reach the internet and then to access this server, so this PC1 IP, that is a private 192.168.1.1, is going to be mapped with what? 100.1.1.1 to reach the internet, right or wrong, right? So one private IP is being mapped with one single public IP to reach the internet. That is fine. Now, what about this PC2? Now, what happened? I am having only single public, no? So if I'm having a single public, with that only single private will be mapped. Rest two PCs has to wait to reach the internet. These two PC has to wait to reach the internet. Why? Because already PC1 has mapped with 100.1.1.1 to reach the internet. It means at one time, what is going to happen here? Only single device will be allowed to reach the internet. Rest other devices has to wait. Correct? That's why it is telling you as what? One-to-one mapping. Correct? Now, if after some time I want that, okay, I want to map 192.168.1.2 with 100.1.1.1 to reach the internet, it will map, but it will remove 1.1. Getting? It will map 1.2, but it will remove 1.1. So what it is always preferring or always it is allowing only one-to-one mapping. Now you know that when we were discussing about the differences between private IP and the public IP, there I told you that this public IP is not free of cost. It is paid. So if one private PC has to reach the internet, it requires a single unique public IP address. And again, one more PC I have, it also required and it is going to be very expensive, right? No? So static NAT has certain demerits, but that too also static NAT will be preferred where? In the reverse direction. Now what we are talking, I am considering that I have to reach internet from PC1, then I have to access this server. Don't you think that this servers also requires a return traffic? Let's say if I want to send one traffic from PC1 to this server, if this server, let's say a Google server, I am searching something, so the content that is present there, I will be getting back to my PC1. Then I will be able to see all the things, all the contents. It means I am sending the traffic, I am receiving the traffic. It means the traffic is two-way. So for that, if NAT is required this side, it means this side also NAT is required. No, correct? So the reason here, it means here what happened that this is my single server. This is my single server. This single server is going to be accessed by multiple different users. So for me, I have to always use what? Only one single IP. That is 10.1.1.2. It's private and it's public 10.100.1.1.2. Okay. It does not require any multiple different IPs. So here in this scenario, static NAT will be preferred where you have a reliable address. Got the point or not?
Yes.
Everyone? So it means that when you are sending the traffic from the client side, in that scenario, you don't prefer static NAT. Where do you prefer? Server side, right? So we can write here static NAT is preferred from the server side, which has a reliable address and has to be accessed by multiple different users. That's what.
So correct. Yeah. So,
So each server will be having different IP. No? So as you know, that servers are very big. Okay, it requires to be accessed by multiple users. So one big servers, one public IP, one private IP, done. Then again one server located at different device location. It is also having one public IP, one private IP like that. Getting? So we write here a common use case of static NAT is when an internal server such as web server, then email server or FTP needs to be accessible from the internet with a fixed public IP address, right? So this one-to-one mapping ensures consistent access without changing the address. Is it clear? Use case of a static NAT. I know. Is it clear? Next. So here we can say that this static NAT will not be preferred from the client side. It is going to be preferred from where? Server side. Then we have one more that is called as a dynamic NAT. In this, multiple private IP address will be mapped with pool of public IP address. Pool of means ranges of public IP addresses to reach the internet. See, according to this situation, here my multiple end devices will be able to reach the internet. That is fine. The reason I am having multiple public IP. But don't you think it is also like a one-to-one mapping only? How? One private will be mapped with again single public to reach the internet. Though the advantage is that all my PC1, PC2, and PC3 will be able to reach the internet. That is fine. But here what will require? Again, multiple individual different public IP. Let's for example that 192.168.1.1 is being mapped with 100.1.1.1. Then 192.168.1.2 is mapped with 100.1.1.2. Correct? No? So it means both the PCs are allowed to reach the internet. That is correct. But this approach is also going to be expensive. The reason you are going to have multiple different public IP addresses. And here also it is preferred, it is preferred when we have limited number of devices. It means I know I have 10 PCs, I require here 10 public, so I will take this. Though it is going to be expensive, right? But it is not much reliable. That's why even we don't prefer much this dynamic NAT. Correct? No? So examples, if you write here, we will be having 192.168.1.1 is being mapped with 100.1.1. Then 192.168.1.2 is mapped with 100.1.2. Then 192.168.1.3 is mapped with 100.1.1.3. This is. So which one is the most preferred one? Most preferred is called as a PAT. The last one. That is called as a port address translation. We can call it as a port address translation, or we can call it as a NAT overload. In this, what happens? NAT overload, I'm telling you. NAT overload. In this, multiple private IP address will be mapped with single public IP address with the help of different port numbers. Okay. Now, why it is required different port numbers? Because see, okay, if I'm having all these three PCs, so it is not that all these three PCs is going to reach a single server. When we use internet, we can use multiple different servers. So, but what happened that 192.168.1.1 is mapped with 100.1.1, right? Again, let me write here only that, for example, here what happened that 192.168.1.1 has been mapped with 100.1.1.1, right? Then again, what happened? 192.168.1.2 is mapped with 100.1.1.1. And 192.168.1.3 is also mapped with same 100.1.1.1. Okay. Now later on, what happened that you are trying to access a server. So if you have a particular server that is going to have a particular IP address, Server is having one IP. Let's consider IP is going to be 10.1.1.1. So when and traffic is coming, so in this, it will come to know that what is my, when it will return the traffic, when it will return the traffic, what it will maintain, that my source IP is 10.1.1.1. What is my destination IP? 100.1.1.1. Getting? Same as if you have one more server, server 2, and any other PC is trying to reach this server 2 that is having IP 10.1.1.2. This is just an example. Okay. So here what it will maintain, again, my source IP is 10.1.1.2 and destination IP is 100.1.1.1, right? So let's consider that this is a PC1 is trying to reach this server 10.1.1.1. For this also, this particular server is sending the traffic to whom? 100.1.1.1. Same as if this PC is there, 1.2 is trying to access a server that is having a IP 10.1.1.2. In this scenario, what will happen? Again, my destination is what? 100.1.1.1. It means that this particular single IP is going to get information from both the servers. Then how it will come to know that this question was asked by 1.1 or this question was asked by 1.2 based on the different virtual port numbers. Okay, so it is going to have a port number here that let's consider this is a port number is 1023. Okay, and this is having a port number 1024. Fine. So 1023 port number has been given to whom? This first IP. And 1024 has been given to whom? The second IP. Okay, now it is clear that this 100.1.1 that is clear, but this is having a port number. So this belongs to PC1. So will be delivered to PC1. Though it is having the same IP, but port number is different, 1024, and this is for 1.2. So this belongs to PC2. Okay. So with the help of this, what is happening here? Multiple different private IP is being mapped with a single public IP. But once it is reaching the internet, it is going to receive a traffic. So for that receiving traffic, it is going to identify that this particular traffic belongs to this particular specific device. For that, it has got one individual virtual port numbers. Who will give these port numbers? Routers will give the port numbers. Okay. From where it will give the port numbers? I have told you that we are having three categories of the port numbers, well known, registered, and ephemeral. So this port number will be of the ephemeral. Clear? Understood this? So all the things is written in the PPT as well. See here. So network address translation is a process in which one or more local IP address are translated into one or more global IP addresses and vice versa to provide internet access to the local host. Correct? So type of NAT we have is a static NAT. Purpose is what? Map one private IP addresses to one public IP addresses. Users often used for a device that needs to be accessible from the outside like a web server or an email server that we have discussed. Correct? No? It means where it requires reliable address. Next, here it is explaining you that here we have one client having an IP, then we have a server that is having a particular IP. So this is the source and this is a destination. And here what require? See, this is my source, this is my destination. But when it comes to that internet size, the my source is changing here. This is not my source. My source is now what? Public IP. And this is what? Destination IP. So when the traffic will come, it is going to be delivered to whom? To this one. Then router will forward it to the this particular client. Right? This is the process of the NAT. Then in this, it is explaining you that we have one client with this private IP is trying to access this particular server. Same as this client is trying to access this particular server. But here what happened, I am going to have a single public IP. So 200.1.1.1 and 200.1.1.2. So this is the example of what? Dynamic NAT. Okay. Private, public, private, public, individually. That's why this is example of dynamic NAT. So what it says, dynamic NAT is what? It maps a private IP address to public IP addresses from a pool of available public IP addresses. Use case commonly used when the number of devices needing to access the internet is less than the number of available public IP addresses. See, the reason, one more thing, that here, if you are going with this part, so here it requires virtual port numbers, but compared to that, this one is simple but expensive. Here, the reason, only one private IP is going to be mapped with single public IP. So no extra overhead is required to add port numbers like that. Simple it is. So map one private with one public IP to reach the internet. But always it requires a single unique public IP that is going to be expensive. That's why compared to this, most efficient is going to be PAT, right? So same, this is having a source IP, destination IP, server. So this is my all the private IP addresses, and every time what is happening here, my IP is being changing, right? Public. As soon as I change my private IP, same as my public IP keeps on changing because of multiple different public. So this is the example of what? Dynamic NAT, right? When my public IP will be same and I will be getting virtual port numbers, in that scenario, that is called as what? PAT, port address translation. See, port address translations or NAT overload we call. So this is what allows multiple devices on a local network to be mapped with a single public IP addresses with a different port numbers for each session. Okay. What is the uses? The most common type of NAT is what? Extensively used in the home and the small office networks. Clear, no? And see this one. This is IP and this is the port numbers and these are the port numbers. See, 49724, 49724, and this is the destination port number of what? Servers. Clear, no? We'll discuss the idea later on. First, we'll do the configuration. So we have taken one router. Take one more router. And then one switch. And one server. Then we'll take how many PCs? Three PCs. Whoever is talking, no. Just wait. I'm going to ask you one question. You will tell me the routing commands. Okay. So let's take IP 192.168.1.10/24. This is going to be 192.168.1.1 slash 24. This is 192.168.1.2. This is going to be 192.168.1.3. Here we have the IP as 100.1.1.1 slash 29, 100.1.1.2 slash 29, then private IP 10.1.1.1, and this is going to be 10.1.1.2. Then come to this router, CLI, give no, enable, config space T, host name is NAT route. Then interface G0/0, IP address 192.168.1.1, okay, 1.10, then 255.255.255.0 and give here no shut and give exit. Then interface G0/1, IP address 100.1.1.1, 255.255.255. What is the subnet mask? It is slash 29. Tell me fast. Hmm?
248.
Yeah, 248. See, I want you all should answer all these questions, okay? Start practicing, I'm telling you. Come to this router, CLI, give no, enable config space T, host name is internet. What is the interface number? G0/0. What is the IP address? 100.1.1.2, 255.255.248 and give no shut, give exit. Right? Then interface G0/1, IP address 10.1.1.1, 255.255.255.0, give no shut, give exit. Done. Now come to this one. Desktop IP configuration 192.168.1.1, 0, and we have to give the default gateway. What is that? 192.168.1.10. Desktop IP configurations 192.168.1.2. And what is the default gateway? 192.168.1.10. Then 192.168.1.3 and 192.168.1.10. Come to this server. Desktop IP configuration. What is IP? 10.1.1.1 or 1.2. Subnet mask 255.255.0. Default gateway 10.1.1.1, right? Now, as you know that this network is in different, like this IP is in different network. Even I have two different routers. To reach here, what is required? Routing. Now tell me the routing commands. Your choice. Static, if you want a static, tell. Dynamic, if you want dynamic, you can tell. Tell the static IP. He will only tell. Hmm. IP route. You take your time, no problem. You take your time, then let me know. That is fine. I know. Now tell me this is a network address. Hmm. You can come here. No? See, give him a seat. He will come here. He will tell us. Tell first the network address. Visual now? Then tell. No, no. IP route I have given. Next, what if I have to give here? You told destination network address. And tell me destination network address. First thing, 100.1.1.2 is not a network address. This is IP address. And second thing, I have to reach 1.1.2. Again, this is IP, no? 10.1.1.0. Next, what is subnet mask? Next, G0/1, 0/0. What we write? Either we write exit interface number or we write next hop. 0/1. I want to write here next hop. I don't want to write 0/1. This one. This one. Next hop will be 10.1.1.2. Okay, Arpita, he is telling that next hop will be 10.1.1.2. He is correct or wrong? Correct or wrong?
Wrong. Wrong,
Wrong.
sir.
So can you tell me what is the next hop here?
This is 10.1 dot 1 dot 10.1.1.2.
Again, I am asking you. See, he told the next hop is going to be 10.1.1.2. Now you only told it is wrong, but again you are telling the same answer. That next hop will be 10.1.1.2. 10 dot or it is going to be 100 dot.
10 dot not sir 100 dot sorry 100 dot
100 dot 1.1.2.
1.1.2 yes.
Okay, yes. So this is the 100 dot 1.1.2. This is the next hop. Done. Okay, now you can set. Now we'll configure here static NAT. IP NAT inside source static. This is the command. IP NAT inside source static. Then what will you write? See here. IP address. Which IP address? Local IP address. I want to map here this first PC. So what is the IP 192.168.1.1? Then what I have to write here? Destination IP. Till where I have to, not, sorry, destination IP. I have to write the global public IP address through which I have to map. What is that? 100.1.1.1. This 100.1.1.1 is what? Public IP, right? So right here, 100.1.1.1. Done. Give a question mark. Nothing is required. It means this is a single line command where you have to write IP NAT inside source static, then the private IP and the public IP through which you have to map this. Done. Then after this, you have to write IP NAT inside source. I will explain you this also. Let me write first in interface G0/0. It is going to be called as a IP NAT inside. Why IP NAT inside? Because this interface is inside. Give exit interface G0/1. This is as what? IP NAT outside. Give exit. Inside means to my local and outside my towards internet. Given. Now, if you will try to give exit here and check here, show IP NAT translations. So IP NAT translations, give enter and see it is showing you that here what happened? 100.1.1.1 has been mapped with what? 192.168.1.1. As of now, we have not tried to ping. That's why it is not showing you. So if you try to ping it from here to the server, ping to 10.1.1.2. Pinging?
Yes.
Now check. Show IP NAT translations. It is present, no? 100.1.1 is mapped with 1.1. This is my outside local and this is my outside global. Okay. Now we'll discuss what it is inside global, inside local, and outside global, everything. Inside local. What is inside local? The location of end devices. The local of end devices or private IP address is called as a inside local. When you have to reach the internet, what is required here? Inside global. The location of public IP address. Okay, the location of public IP address is called as a inside global. Okay. Then outside global first. Outside global means the internet connectivity. That is outside global. Then what is that outside local? Yes. Outside local location of server. It means if you have a laptop at your home, so this is going to be inside local. It require a public IP to reach the internet. So that public IP that is helping you to reach the internet, that is inside global. Then you have outside global where you are able to reach the internet. You got the net connectivity. And then from that net connectivity, you are trying to access a particular web server. That particular web server will be what?
Outside.
Outside local for you. Got?
Yes.
Or do you want any other example? You are sitting at your home inside local. You want to go out from your home. What will you use? Your main gate. What is that? Inside global. That is acting as a main entrance or exit point from where you can go out from your home. That's why it is called as a inside global. When you went out, you went to a shop. That is for you what? Outside global. And you ask the shopkeeper to bring a packet of biscuit for him. So from where he's going to bring that? From his shop only. That particular biscuit will be outside local. This is how you are able to reach internet. No, you have end devices. That is called as inside local. It is having a private IP. To reach the internet, it requires what? Public IP. That is inside global. Once you got the net connectivity, that is outside global. After that, you are accessing a server outside local. Okay. So in this diagram, in this topology, this all this is the where the my end devices are located. This is called as what?
Inside local.
Inside local. Okay. Now, this is my public IP, no? So this is helping me to reach the internet. So this is called as a inside global. Okay. And here I have reached the internet. So this is my internet. And this is called as a outside global. And this is outside local. Okay. Clear? Now, when we have given this command, so here what is happening? That this particular single IP has been mapped. Now, if we will try to add one more, let's say config space t, give command ipnat inside source static, and private IP is going to be 192.168.1.2, and my public IP will be what? 100.1.1.1, right? Now you give exit and check show IP NAT translations. What happened? 1.2 is mapped with 100.1.1.1. But what about this 192.1.1.1? It has been removed. Even if you try to add one more new, come to config space t and give here IP NAT inside source static and 192.168.1.3 and 100.1.1.1, and again give a exit and check show IP NAT translations. So 1.3 is mapped, 1.2 removed. Okay, so write down the commands. One more thing, in the access list, we have not written that. So how to check? So this one is show IP access list. And for the static NAT command, IP NAT inside source static. Then we write what? Private IP. And then we write public IP. Inside source static means you are referring here which inside, which is my inside IP. Inside source is what? By private IP. Okay. Then a static, the method I'm using here static. Then I have to write here my private IP and the public IP through which it has to be mapped to reach the internet. Okay. Then you write what? Interface, interface number, IP NAT inside, one more interface, and interface number. After this, IP NAT outside. Clear? And remove the static NAT. Come to config space T. Give no. Okay. Next. Now when you verify, show IP NAT translation, it is not showing you because we have removed this. Now we'll do it dynamic NAT. See, for this dynamic NAT, we have to create an access list. Okay. So this time what you want, that you want to permit all these three IP to reach the internet, right? So for that, you have to create a list to permit all these three IP. How will you permit? Access list. Then you will give here what? A ACL number. Let's say I'm going with the standard one. So I will give here one. Now we used to give always deny. This time with what we will give? Permit. Now what I have to permit? The IP. Okay, but not IP, the network address. All IP coming under this network. 192.168.1.0. If I am writing a network address, it means what will happen? All the IP coming under this network will be allowed. Okay, next what I have to write? Wildcard mask. As I told you that when you are writing for a specific PC, you will write 0.0.0.0. But here I am taking network address. So what I will write? 0.0.0.255. Okay, given. Then IP NAT. IP NAT, you will give here pool. It means first we want to create a pool. IP NAT pool. That's why I want to create what? Ranges of the public, no? So IP NAT pool. Then we have to give a name to this pool. Let's say I'm giving pool P1. IP NAT pool P1. Then what I have to write here? Starting IP address. 100.1.1.1. Again, give a question mark. What I have to write here? End IP address. 100.1.1.3. Let's say I have got three ranges of the IP from the internet, from the ISP, that is 1.12 or 1.3, right? Next. So that's why I'm creating a range. What it is writing here? Net mask. Net mask is same as submit mask. The term is different. Net mask. Okay. That's all. So what we have given? IP NAT pool P1. Then we have given a source means ranges of the IP address of the public IP only. And then at last, what we have given? Net mask. And what is the net mask we have to give? 255.255.255.248 slash 2090. That's why. Done. Then after this, IP NAT inside source. Then do not write static here because this is not the static. Inside source list. It is asking you list. Which list? What is your source? The list one, no? This is my source, no? Means my source is 1.0. And where this 1.0 is present? In my access list where that I have created with the ACL number one. This is my list number one. So that's why you will write here what? Inside source list one. Okay. And what is the destination? The destination is going to be the pool. The pool name that we have given. What is that? Pool. And what is the name we have given? P1. It means instead of writing this particular network and this particular ranges, what you are writing here? The list one and pool P1, that's all. Because you only have given no. For this network address, this is my list number. For this, my ranges of the public IP, this is my pool name. That's why. That's why we have given IP NAT inside source list one and pool P1. That's all. Done. Now you have to implement on the interfaces. So for that interface, G0/0 IP NAT inside, then interface G0/1 IP NAT outside. Done. Now you try to ping. So come to command prompt. We'll try to ping to 10.1.1.2. Okay, we'll not give enter now. We'll give enter at the same time. Check. Show IP NAT translation and see here. Right. So this is my 1.2 is mapped with what? 1.1. Then this is going to be 1.1 is mapped with what? 1.2. 100.1.1, 1.2. 100.1.2 is mapped with 1.3. It is not showing exactly, but it will show that 1.2 is mapped with 1.3 and 1.1 is mapped with 1.2, and it is also showing for this one also. But it will not happen in the reality. It will be individually mapped. Okay, sometime when you remove static NAT, because of that, sometime it happens. But in the real scenario, it will be mapped with one and like this, similar. Okay, no. But when we will use dynamic PAT, that is port address translations, you will be having all single public and all different private. Clear? So write down the commands for the dynamic NAT. Access list, then ACL number, permit, network address, then wildcard mask, IP, NAT. No, what is that? IP NAT, no.
Yeah, IP NAT pool.
We have to create access list to permit the traffic.
But by default, it will be permitted.
By default, but how you are referring here, which we have to permit?
So that we can refer to that number in the command.
So that we can refer to that particular number that we have created in that command. That's why we are using this. Because you are defining that this IP coming under this network should be mapped with my public IP. For that, we have to define this. That's why we're using ACL. You can go with the name also. Okay. So IP NAT pool, and then we have to give a pool name. Then what we write? Means starting public IP
address.
and public IP. Then netmask. Then we write here what? 'subnet mask'. then IP NAT inside source list, and we write here list number, then pool and the pool name that we have given. Your end device's network address, no local address, where your end devices has been located. Interface number, IP NAT inside, then interface number, IP NAT outside. So static NAT and dynamic NAT has been completed. On Monday, we'll discuss port address translation. And then we'll start with switching part VLAN. Okay, first we'll do VLAN, inter VLAN, DTP, VTP, STP, RSTP, Ether channel. Then we'll start IP version 6. Okay, after IPv6, then we'll go with DHCP, DNS, TFTP, FTP, then CDP, LLDP, wireless, automation, AI, cloud basics. And on Monday only, after completing this NAT, we'll do FHRP before starting VLAN. These are the topics left. Fine. So we'll stop the recording.